Okay, so we have here the first example of finding the volume by cross-sections of a figure. And the first thing I'm going to go ahead and write down is that formula from the previous video, where it's the volume from A to B of the area function dx. That's going to be very important. So the first problem says a solid is made of square cross-sections. So in the previous video, the cross-section on the pear, that was a semicircle. This time it's going to be square cross-sections. That's important. They're perpendicular to the x-axis, and our job is to find the volume of the solid if the cross-sections are bound by this function here. Now, if we were to graph this function, you may or may not recognize that what it actually turns into is the top and bottom of a circle. You see, the equation for a circle centered at the origin would be x squared plus y squared equals 4, or 2 squared. And what you'll notice is if I try to solve for y, I get exactly this equation that I have here. So this is actually representing the top, the positive square root is the top, the bottom would be the negative of a circle. Okay, so it creates a circle with radius 2 because 4 is r squared. Okay, so that's really what it's creating. Now this is a little hard to visualize, and I have a program to help us, but what really is happening is that imagine that this is the base of your solid. So imagine laying this down as a flat paper, and what you are then going to do is draw squares, and those squares are going to start at the top of the semicircle, and they're going to go to the bottom of the semicircle, and then they're going to stick out. So this is sort of the base of that square, and then you're going to go out towards you. Imagine poking outside of the screen towards you is going to be the top of that square. So one more time, this is like, imagine this is laying flat on the paper, and then this is the base of that cross section, and it's going to stick out towards you. So what you'll notice is as you go to the center here of the circle, the rectangle gets wider or longer, and as you come out here to the edge of the circle, the rectangle starts to get smaller, or the square gets smaller. Now I want to go ahead and help you visualize that, so I have a program. Here we are. Imagine that this is, just a moment, let me get my writing tool. This is your circle, top circle, bottom circle. They set this for r squared, but for us it's going to be 4. So this top piece is simply going to be y equals the square root of 4 minus x squared. The bottom piece will be y equals negative square root of 4 minus x squared. And like I told you earlier, we're going to draw cross sections from the top to the bottom, and then they're going to stick out towards you. So let me drop this axis so you can see. Okay, so there it is, drop. Now I'm going to show you the squares, that there's 4 squares. So again, you need to imagine that these squares start at the top of the circle and then they go to the bottom. And as I go to the center here, the origin, you can see that's going to be the longest rectangle or square. And as I come out to the end, they get smaller. So let me get rid of those and show you one more time. Okay, so there's my axis. I'm going to drop it so you can see it. Now I'm going to sweep one square so you can see how it changes. See that? As it goes to the center, it's going to get very long, and then as it comes in, it's going to get smaller or less, less tall, less wide. So these are the cross sections. These squares are the cross sections. What you need to imagine now is that what would the solid look like if we were able to just stack all of these squares right next to each other? And what would the solid look like? And again, you would imagine that the solid here along the y-axis is going to be the tallest, and then it gets not as tall as it goes to the end. So I'm going to have it create the solid this time so you can see it. There it is. And it looks different than what you would expect, but that's what these squares stacked right next to each other would create. Okay, there it is. So I'll go ahead and show you the solid. I'll put the 4 squares so you can see them. That's how the squares fit in. That's what they're creating. And I'm going to slide one square through the solid so you can see exactly. This is just the visual. Okay, and I'll go ahead and rotate the axis so you can see better. All right. So when you look at it on your paper, what you see is basic. I want to stop it right there. Reset it. What you see on your paper is that the squares. You don't actually see the squares. If you're looking at it top to bottom, you just see these lines. Because you have to imagine these are really skinny slices. So when you look at it from the aerial view, you're basically just seeing this line. Okay. See, so there's my solid. It doesn't look like anything until I drop my axis and I can see, oh wait, it's sticking out. That's why I couldn't tell. But if I look at it from an angle, that's what the solid looks like. Okay, so what our job is going to be is to figure out what the volume of this solid is. And the formula for that we already wrote down. The formula for this is simply going to be the following. It's the integral from A to B of the area function of each of those cross sections. It's very important that you realize a cross section in this instance is a square. So my cross section, the area of it is simply going to be basically the base times the height, which they are the same, so it's the base squared. I'm just going to use B for base, or just write the whole word. It's the base squared. Because the base and the height are the same in a rectangle, so base times base squared. So we need to put that in terms of x. And I'm going to ask you to think about what would then be the base of this function, of this square. Well, if I pick this blue square here, I'm going to get one answer. But if I pick the black square, I'm going to get a different answer. And the purple one or the light pink one, they're all going to have different sizes. Because depending on where you are on the x-axis, there will be the size of that rectangle. So what you basically have to do is imagine that your rectangle starts at the top of the semicircle, of this portion of the circle, and it goes all the way to the bottom. So simply put, the base of this square is the distance from the top of the circle to the bottom of the circle. Okay, that's it. The top of the circle to the bottom of the circle. And I'm going to go ahead and erase this and drop my axis back where I used to be so I can show that to you. So each of these squares goes from the top to the bottom. So if I want to come up with a function for it, all I really have to do is take the top function and subtract the bottom, and that'll give me the distance from the top of the circle to the bottom no matter where I am. See, depending on what x you pick is going to change how far the top is from the bottom of the circle. So the base is squared is simply going to be the top of the circle minus the bottom of the circle, which is negative square root of 4 minus x squared. And what you notice is you get two negatives, which become positive, and I get 2 square roots of 4 minus x squared. Okay? And that is going to be just the distance from here to here. So that would have been the base from the top to the bottom. But remember, we don't just need the base, we need the base squared. So we're actually going to square this, and we're going to get 4 times the square root goes away, so 4 minus x squared. So the 2 became 4 and the square root went away. This is our area function. It's the distance from the top of the circle to the bottom, and it gets squared to give you this expression. So going back to our formula, we simply have to do the integral from A. Well, you're going to ask me, what's A? Well, A is where the solid starts. If you remember, this circle has a radius of 4. So that means we start at -2 and we go to, sorry, the radius squared is 4. So the radius then would, of course, be 2. So that means that we're actually starting from -2 and we're going to +2. So the integral will be from -2 to 2. The area of each square is depending on which x point we're on. And the distance from the top to the bottom we agreed was 2 square root of 4 minus x squared. When you square that, because this is a square, the area is the base times the base, we end up getting 4 times 4 minus dx. And you're simply going to put that into your calculators, Math 9 this, and you should get that the answer is 42.67. And that's it. That's how you do these. The hardest part of these problems is figuring out the area function based on the functions that they give you. So hopefully this made sense, and you can check out the next video. What we're going to do is we're going to take the same exact function, but we're going to change the cross sections, and instead of using squares, we're going to use triangles.